Hello again, and welcome to Statistics with Dr. David Bug. Today we're going to take a look at how to calculate a t-test to do hypothesis testing to see if there is a significant statistical difference between the means of two groups, where the groups represent categories of the independent variable and how they affect our dependent variable. So, how do we calculate a t-test? Let's take a look at an example. Do female and male college students differ in their concern for employment prospects after they graduate? Let's say we have two groups, a group of males with a total number of 35 men in the sample, who on a score of concern for employment prospects have a group mean of 6.2 with a variance of 6.22 points. And the female group also has 35 members with a mean of 5.4 points for concern for employment prospects, with a variance of 4.98. Now, to calculate a t-test, to determine if the difference between the two groups is statistically significant or the result of sampling error, we must take the following steps. Now, for most people, we would begin by calculating the mean for each group or sample. But since you've already done that in previous lessons, I've given that information to you. But many times this is our starting point. We take our raw data and calculate a mean for each of the groups we're comparing. Then, in step 2, we calculate the variance for each group or sample. Again, we've already learned how to calculate a variance in previous lessons, and so that information has also been provided to you. So the first step that we actually have to take that's new for us so far is we have to calculate something called the standard error of the difference between means. And that's represented by the formula here. Now this formula has a lot of letters in it, but it's actually really not that difficult. It just looks a little crazy. Really, all we're solving for is a few things. We're solving for our S subscore mean of group 1 minus mean of group 2, which is known as the standard error of the difference between means. And the only thing that goes into the actual calculation itself are the total number of cases for group 1 and group 2, represented by N1 and N2, and then the variance, which is S squared, for both group 1 and group 2. So let's move on and take a look at how we would take the provided information for us and plug it into this formula. So, solving for the standard error of the difference between means. Under our square root symbol, in our first portion on the left side of the equation, we have there the total number of males, 35, multiplied by their variance of 6.22, and then we add to it the total number of females, 35, multiplied by their variance, 4.98. And we put this over N1 plus N2 minus 2. So the total for group 1 was 35. The total for group 2 is 35. Add those together and then subtract 2 from that. Then once we've done with that step, we multiply the whole thing by N1 plus N2 over N1 multiplied by N2. And so we've plugged in 35 for group 1 plus 35 from group 2 over 35 for group 1 multiplied by 35 for group 2. So we're just using two sets of values in multiple places until we've fulfilled all the requirements for the equation. Now we can start by going through and doing the multiplications and additions and subtractions and other things in the numerators and denominators until we get to our next step. So 35 multiplied by 6.22 equals 217.7, and to which we add 2 for group 2 values, 35 multiplied by 4.98, which equals 174.3, over the 35 plus 35, which is 70, minus 2, which equals 68. Then we're going to multiply that by 35 plus 35, which is 70, over 35 multiplied by 35, which is 1,225. So now we're just going to do that little addition that we have left over. So 217.7 plus 174.3 equals 392. So we have 392 over 68 multiplied by 70 over 1,225, which gives us 5.7647 multiplied by 0.0571. And multiplying those together, we end up with 0.3294. Taking the square root of that, we have a value of 0.574, which is the standard error of the difference between means for this problem. Moving to step 4, we can calculate the t-test or t-ratio. So to compute the t-ratio, we're using the formula t equals mean of group 1 minus mean of group 2 over the standard error of the difference between means. You may notice this looks like a z-score formula, except instead of subtracting a mean from a raw score, we're now subtracting a mean from a mean and dividing by the standard error of the difference between means instead of standard deviations. So plugging our numbers into our formula, our mean for group 1 is 6.2, and now we're subtracting from it our mean for group 2, which is 5.4, and putting that over our standard error of the difference between means, which again from step 3 was 0.574. Doing the subtraction, we end up with 0.8 over 0.574, and doing that division, we end up with a t-value of 1.394. Now, on to our next step. Now we have to figure out what is the critical value for t. And this is the t-value based upon our table. You have a table on Brightspace for t-tables, and so now we have to calculate what value do we need to exceed to be able to reject the null hypothesis that there is no difference between male and female groups on their concern for their job prospects in the future. So to do this, we need to calculate degrees of freedom, which we've already done, but just to slow it down once and show you one more time, degrees of freedom equals the total of cases for group 1 plus the total of cases for group 2 minus 2. So our total number of cases for group 1 is 35, and our total number of cases for group 2 is also 35. So plugging into the formula, 35 plus 35 is 70 minus 2 equals 68. Now, assuming an alpha level of 0.05, which is probably the most common alpha level in the social and behavioral sciences, we can look up an alpha level of 0.05 and the t-value that we must meet or exceed to find a statistically significant difference is a t-value that equals 2.0. Now, we can compare and see how we fare. So comparing the calculated t-value to the table value for t. So we compare our calculated value of t equals 1.394 to the table value that we've looked up, which is t equals 2.0. Since the calculated value is less than the table value, we must retain the null hypothesis, H subscript O, that says that there is no significant mathematical difference or statistical difference between group 1 and group 2. So basically, even though the values of the means for both males and females are numerically different, they are due to sampling error and not because the gender of someone affects their ideas about their prospects for the future job after college. What does this mean in real life? Well, in real life, it probably means that we're going to go looking for a new independent variable to explain what affects our dependent variable. of concern for college, for job prospects after college. So, I'll see you again in another video.